Hi everybody, welcome back to my channel on Feynman integration. I figured since I had used the integrating factor technique in two of my other videos, I better explain it. So an integrating factor is something used in differential equations to solve first order linear differential equations of that form for y, where y is a function of x. So if you have a differential equation in that form, the integrating factor is how you solve it. Basically, you choose your integrating factor so that when you multiply both sides of the equation by the integrating factor, this part right here becomes the result of a product rule for derivatives. So let's really quick recall what the product rule says. If you have two functions, a first and a second, both of x, and I know this is really screwy notation, but I just like it's kind of more plain English. But anyway, we have a function that is the result of taking some first function times some second function, and then we take its derivative. That's going to be equal to the first function times the derivative of the second function plus the second function, times the derivative of the first function times the second function. You guys all know that. Okay, so we need this to match this because, well, we want it to be the result of a product rule for derivatives. Okay, so let's just start matching terms up. We have first times derivative of second. Let's match it up with the first term in our original equation there. Okay, well, we already have a derivative, so let's match y prime up with the derivative of the second. Therefore, if the derivative of the second is y prime, then that means our first is r of x. That's written right there, as well as the derivative of our second being equal to y prime. If the derivative of our second is equal to y prime, the second must be equal to y. Well, if the second is equal to y, which is in this part right here, that means that our d first must be r of x times p of x, which is right there. And our d first, of course, is the derivative with respect to x of our r of x. So we have r prime of x being equal to r of x times p of x. I know I'm moving pretty fast. I hope this all makes sense. Okay, so we're right here. We've figured that part out. Well, okay, so we have some function r of x such that if you take its derivative, you get back r of x times some other function. Well, that motivates us to make the guess that our r of x is going to be an exponential equation of the form like e to the question mark of x. I know you really shouldn't use question marks for notation, but I like it. Okay, so let's rewrite this a little bit. R prime of x, since we guessed that our r of x is going to be e to the question mark of x, we can rewrite r prime of x as d dx e to the question mark of x. Well, let's take the derivative using the chain rule. We'll get back the original thing, e to the question mark of x, times the derivative with respect to x of this part right here. It's written right there. And then again, noting that this part is simply r prime of x and this is simply r of x. Okay, so this part matches with that. This part matches with that. Therefore, this part must match with that. In other words, our p of x must be equal to question mark prime of x. Therefore, our question mark of x must be equal to the integral of p of x. So, since our r of x is equal to e to the question mark of x, and we determined that question mark of x is equal to the integral of p of x, our integrating factor is always going to be e raised to the power of the integral of whatever our p of x is. And then when you find that integrating factor and multiply both sides of the equation by it, the left-hand side will be guaranteed to be the result of a product rule. And let's just do a really quick one right now. Let's just say that, and it's going to be super simple. We're just going to say that y prime plus y is equal to 1. It's got all the parts, right? Our p of x is just 1. Our q of x is just 1. So let's go ahead and find our integrating factor for this. Our integrating factor is going to be e to the integral of p of x. Well, that's going to be e to the integral of our p of x is just 1. So that's going to be e to the integral of 1, which is just e to the x. All right, so now we know what we need to multiply both sides of the equation by to solve this. All right, so let's do it. Let's multiply both sides of this equation by e to the x. So we have y prime e to the x plus y e to the x is equal to e to the x. All right. Well, we said that this has to be the result of a product rule for the derivatives, and it is. It is equal to y times e to the x prime. First times the derivative of the second. There it is right there. Plus the second times the derivative of the first right there. And it's going to work every time, I promise. And you should see that from the work we've done. But anyway, okay, so great. We have that. All right, so we're trying to solve for y. So let's, since we have a derivative on this side, let's get rid of it by taking an integral. So we'll just integrate both sides of that. And I'm not using dx's and things like that. So we'll just basically get that y times e to the x, because that is the integral of y e to the x prime. That is equal to the integral of e to the x, which is just e to the x plus c. So now to solve for y, all we need to do is divide both sides by e to the x, giving us y is equal to, let's see, 1 plus some constant over e to the x. All right, divide that by e to the x, divide that by e to the x, divide that by e to the x. There you go. And that's the solution to that differential equation. Let's just check it. Let's see if that's actually true. All right, I'm going to rewrite that as c times e to the negative x. All right, so we're claiming that y prime times e to the x plus y e to the x, y prime plus y is equal to 1. Well, what's y prime? Y prime, in this case, would equal, let's see, that would go away, and then we'd be left with a negative c times e to the negative x. And our y, of course, is just this. So let's add them together. Y prime plus y is equal to this plus this, and you can see that it will be equal to 1. There you go. So that's the explanation of the integrating factor, which I've been using quite a bit on this channel. And I use it to solve a very simple first order linear differential equation. That's my video. Hope you enjoyed it.